Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for Wednesday night, January 4th. We are continuing to solve systems by elimination. All right, when you have a system that looks kind of like this, oh no, I'm not in right mode again. 3x plus 4y equals 12, and say 2x minus 2y equals 10. Most of you know, hey, I'm going to eliminate those y's in this case because it's really pretty simple. All I have to do is multiply this second equation here by a 2. The coefficients of the y terms will match but be opposite signs, one positive 4, one negative 4. And then I can add the equations together, and I will turn my two equations with two different variables into one equation with one variable, and then just use my steps for solving equations, aka Saddam, and find out what the other variable is. Things change a little bit though when it looks something like this. Okay, now it's not really that much more difficult, though it is a step longer. What I'm going to do is I'm going to decide, I'm going to look at my x's and their coefficients, and I'll also look at my y's and see which one I think it would be easier to eliminate. You see, in the last one, we multiplied one of the equations by a number to get the coefficients to match. In this situation, we're actually going to multiply both equations, but we'll multiply them by different numbers. We'll multiply them so that we can get either the coefficients on x to match with opposite signs or the coefficients on y to match. What we're really looking for is the least common multiple. And I know you guys get scared of that term, but it's really simple. What's the least common multiple of 2 and 3? In other words, what is the smallest number that both 2 and 3 go into? Well, an easy way to do this is to count by the larger number. And I'll stop when I get a number that the smaller number divides into evenly. 3 is larger than 2, so I'm going to count by 3s. I'm going to go 3, 6, stop! Why did I stop? Because 2 will divide into 6. So, one approach I could take is to make both of my x coefficients turn into 6. I could also, if I had wanted to, I'll do it the x way, but I'll talk about the y way for just a minute. I could look at 4 and 3. 4 and 3. I might choose to eliminate the y's because the 1 on y is already negative. I don't have to multiply by a negative. All right. Well, I'm going to count by the larger of the coefficients, which would be 4. I'll stop when I get a number that the 3 goes into evenly. So 4, 8, 12, stop! 3 goes into 12 evenly, doesn't it? Absolutely. Now the red one might be a little bit less work, like I said, but I'm going to do it the blue way. But I'm showing you both so that you can understand what's going on. You don't always get rid of x. You don't always get rid of y. You have to have in the number sense to decide which one to get rid of. Well, the first thing I'm going to do is I'm going to multiply this first equation. And here's how I know what to multiply by. 6 is my least common multiple. How do I turn 3 into 6? Well, I have to multiply it by 2. But if I multiply by 2 on the left-hand side, I must do the same on the right-hand side. That will transform this first equation into 6x plus 8y equals 24. I multiply the left-hand side by 2, which means I distributed, and then I multiply the right-hand side by 2. 12 times 2 is 24. Now I have to do it on the bottom, but I'm not going to multiply by 2 because my goal is to make this coefficient here match 6x with an opposite sign. Well, I'm going to multiply by 3. Only if I multiply by 3, I'm going to get a 6x. So I'm not going to multiply by 3. I'm going to multiply by negative 3. Negative 3 times 2 is negative 6x. Look at that. They match. Okay. Negative 3 times negative 3y is a positive 9y. And then I have to multiply the right-hand side by negative 3 as well, and I will get a negative 30. Now I can go ahead and add my equations, And it looks like those will cancel. I'll have 17y, and I'll have a negative 6. Dividing by 17, y is going to equal negative 6/17, which is an ugly answer. You know, I like fractions, but this is an ugly one. This is a case where I'll go to a decimal. Negative 6 divided by 17, and that's approximately negative 0.35 and 3. I'll go 3 decimal places. Usually 2 is sufficient, but I'll go 3. All right, now remember, I'm not done. I have to go and figure out what x is. And I think I'll use the 2x minus 3y equation. I think that one will be just a little bit friendlier. 2x minus 3y, and that equals 10. So that means that 2x minus 3 times negative 0.353, that'll equal 10. I just substituted y's value into the equation. Okay, let me see here. I'm going to have 2x plus, let's see, that's going to be a 9, there's going to be a 5, a 0, and I think it's going to be 1.059 times hundreds, thousands, 1 and 59 thousandths. Okay, so then I'll have 2x, which will equal, let's see, that's going to be 8.941, I believe. I subtracted 1.059 from both sides. Yes, I do like that answer. All right, so then I'm going to divide each side by 2, and x is going to be 4.4, 14 be 7, 0, 5, and, you know, this is a cool answer here, 4.47. That's good enough. So we'll go 4.47, 4 and 47 hundredths, and y, I forgot what y was, negative 0.35. If you want to drop that last 3 off, you can. You can put the last 3 on. It's only a decimal approximation. Okay, you can see how this would be a pain in the butt to solve using graphing. Okay, let's look at another one. By the way, these numbers are coming up ugly because I just made them up off the top of my head. But usually the problems we give you on tests and books from homework won't be so bad. But if you can do these, then it might be okay. Might be easier to do the hard ones. It'll be easier to do the easy ones. Sorry, thinking about too many things at once here. Okay, this time I'm going to have 2x, and we'll make a minus. No, we'll go with negative 2x plus a 4y, and we'll make that equal to, I don't know, let's go 24. Okay, on this one, I've got to decide, do I want to get rid of my x's or my y's? Well, getting rid of the x's would mean my least common multiple of 5 and 2, 5, 10, stop, would be 10. I have to turn both the x coefficients into 10. The least common multiple of the y's would be 6, 12, stop, would be 12. I think I'm going to do my x's. So I'm going to multiply this top equation here by 2. And I'm going to multiply the bottom equation here by 5. Okay, doing so, the first equation will give me 10x plus 12y. That'll equal 60. I forgot to put the 2 there. Sorry about that. The second equation will give me negative 10x plus 20y. And that will equal 120, I believe. So I add them together. Oh no, I can't see what I'm doing anymore. Those will cancel. I have 32y, which will equal 180. Y will equal, and I'll go right to a decimal on this one, 180 divided by 32, about 5.625. It's actually 0.65 is a pretty fraction, so I'm going to leave all 3 there. All right, now I've got to solve for x. And think I'm going to plug it into first equation. So I'm going to get negative 2 times 5.625. I can't see my plus 4y equals 24. Plus 4y equals 24. Okay, I don't know why I did that, but that's okay. We're going to get a 0, carry the 5, we're going to get a 2, we're going to carry the 1, and it's going to be negative. Okay, so we're going to get 4y is going to equal 35.250. We'll divide each side by 4 to get y is equal to, hold on, 8.8125. All right, so x was 5.625 and y was 8.8125. And again, I would accept, 5.63, 8.81. That would be an acceptable answer because we're only getting an approximate here. If you went fraction, of course, it would be an exact answer. Of course, if you were really lazy and went like this, and the directions did not specify what place to go, that would be acceptable. So if the directions say to the nearest tenth, nearest hundredth, nearest thousandth, you have to do that. But if they don't, you can be free to round. Don't round it to a whole number unless it's something like 8.99999. That would round to a whole number. Okay, that's your lesson for today. Remember, the midterm is coming up quick. It's planning on being next Wednesday, so a week from today. All right, Mr. Lawrence signing off.